So in this example, we're going to look at a method of undetermined coefficients problem that involves repeating in the forcing function a root that also solves the homogeneous function. This is a particularly tricky one because you can get really confused if you forget to account for the root of the homogeneous solution when you make your guess for the particular solution. You can get a lot of nonsense like a equals 3a equals 0 or a equals a or other kinds of nonsense that you can't solve for. And so what we're going to do is we're going to then look at how to account for this repetition. And this is why we solve the homogeneous solution first before we make our guess. So we're going to look at our differential equation. We've got y double prime plus 8y prime is equal to x minus cosine x. So this is our forcing function, and so we're going to solve the homogeneous problem first. Double prime becomes r squared, prime becomes r, and so r squared plus 8r. And if we factor this, we're going to get r times r plus 8. R times r plus 8 equals 0. And that's why we get r equals 0 and r equals negative 8 as solutions to our differential equation. Now, e to the negative 8 is from the negative 8, e to the negative 8x. And then the constant r equals 0 is c1 times e to the 0x. But e to the 0 is just 1. And so we just get this constant sitting right here. Now, normally we would want to make a guess of, initially we're thinking yp should be ax plus b, because for our polynomial we need to take the x and then all the terms lower than that, and then c sine x plus d cosine x. Because for the trig functions, of course, you need to take both sine and cosine. But this is not going to work. And the reason this is not going to work is because this b right here is one of the homogeneous solutions, and so I can't keep it. So what I have to do is I have to multiply my polynomial portion, the part that has the thing that's repeated. I have to multiply that whole guess by x. And so that's going to give me ax squared plus bx. And again, the reason for this is because if I leave the b and I take the derivative, it's going to satisfy the original homogeneous function. And so I'm not going to get anything for that variable. And so none of this is going to work. So by multiplying it, I can get that constant to survive coming through the homogeneous equation. Okay, so my guess then is ax squared plus bx for the x portion and c sine x plus d cosine x. That is not part of the homogeneous solution, and so I don't have to worry about multiplying it by x because it's not the part that's repeated. And then we continue to go through our process. So we take our derivative, so 2ax plus b, and then sine becomes cosine, and cosine becomes negative sine, and then I take my second derivative, and I'm left with 2a, and then cosine becomes negative sine, and sine becomes cosine. And then we plug these things into my differential equation, which I only need these two things for. So this portion is my second derivative from up here, and then 8 times my yp. So 8 times this is going to become 16. And 8 times this is going to become 8. And 8 times this is going to become 8c. And 8 times this is going to become 8. And then, just like before, we're going to try to combine like terms. So on this side of the equation, I don't have any x squared terms. And on this side of the equation, I don't have any x squared terms. So I'm doing this just for the sake of completeness, but I have nothing and I have nothing, and so that's fine. Then I need my x terms. So I have a 16x equal to 1x. 16ax equal to 1. That's easy to solve. 1 out of 16. Then I take my constants. I've got my 2a, and I've got my 8b, and I set that equal to 0. Because I don't have any constants over here. And again, notice my c did not, I don't have a constant, and it didn't show up anywhere. So 2 times 1 over 16 divided by 8 get 1 over 64. And then I combine my sign terms. I've got sign here and I've got sign here. So negative c and negative 8d is equal to 0 because there's no signs over here. And then cosine, I've got 8c and minus d is equal to negative 1. And so I'm going to put this into a matrix and I'm going to solve this. Or you can do it by hand. It's probably not too difficult. But if you have linear algebra knowledge, this is a good place to use it for. And so what we end up with is c equals negative 8 over 65. And d is equal to 1 over 65. And so then we put those into our solution to our differential equation. A is 1 over 16, B is that, C is 8 over 65, and D is 1 over 65. And so when we combine these into our original problem, we add in the homogeneous portion in order to show the final general solution that we can then use to solve for C1 and C2 if we're given initial conditions.